Look at 2016, number 1. So we have the table of values here. Water is pumped into the tank at the rate of W of T. So that's how much water is going into the tank. And then what is removed from the tank modeled by R of T, so which is table right above here. And then it's differentiable and decreasing from 0 through 8. Now, one thing that they told us here was when T was equal to 0, there are 50,000 liters of the water in the tank. Estimate R prime of 2. So now, when you look into this one, I don't see 2. I see 1 and 3. Then how are you going to estimate R prime of 2? Then you're going to be using the value around it. Meaning, we're going to use the average rate of change to estimate instantaneous rate of change. Idea of the mean value theorems, very similar. So now, but not exactly, but similar. So what we end up doing is R prime of 2 can be approximated by R of 3 minus R of 1 over 3 minus 1. That's the calculation that which we like to do. Now, what is that equal to? Then that's equal to 950 minus 1190 divided by 2. That's equal to, when you use calculator, you're going to get negative 120. Now, they want you to indicate the unit of measures. So then, since I'm taking the derivative of R, so liters per hour, divide by hour. So that means liter per hour square. That would be the unit of measures. All right. Part B, use the left Riemann sum with the 4 subintervals to estimate the total amount of water removed from the tank during the 8 hours. So that means I need to use this table and then use a left Riemann sum to estimate the value. Now, that's the first part. Second part is this an overestimation or underestimation? And then we want to talk about that based upon increasing or decreasing function. So here it goes. Part B, which I'm going to do it over here. So then volume that which we are looking at is from 0 through 8 of R of T dt. This can be approximated. They want you to use the left Riemann sum. So this will be the first rectangle. That will be the second, third, and fourth in that way. And for the first rectangle, we have to use the left value. So we get 1340 multiplied by the difference between these two, which is 1. Plus second one, within the second rectangle, we have to use the left side, 1190 multiplied by the difference, which is the 2. Now third, here, third rectangle, but I'm using the value on the left side, which is 950. Multiply that by what? 3. Difference of 3 and 6 becomes 3. Now, plus the last rectangle is 740 times the difference between those two is what? 2. Then we get to realize that this, when you put them into calculator, you should be able to get 8,050. And then our unit is, you got to multiply those two things. So liters per hour times hour becomes simply liters. Now, is this an increasing or decreasing? Is this an over and all underestimation? So when you look into this one, generally, when you look at the values, they're all decreasing, as you can see. Graphically speaking, when the function is decreasing somehow, and if you're to use the left Riemann sum, it will always be the overall estimation. So the question is, this is an overestimation because the function is decreasing. All right, so that's what we can say. Alrighty, let's look at number or part C. Use the answer from part B, which is what we just figured it out right over here. To find the estimate of the total amount of the water in the tank. They want you to estimate the amount of water in the tank at the end of the, so to the nearest liter at the end of 8. So this is how much of the water has been removed. Then my question to you is how much of water has been poured in. So total amount, I can say, let me call that as A. Total amount would have been equal to, at the end of 8 o'clock, so I'm gonna, 8th hour, would have been simply amount of water that came in, which was 0 through 8 of W of T dt, and then minus 80/50, that's the amount of water that has been removed. But we shouldn't forget, originally there was 50,000. That's basically what we have to calculate. So what I'm going to do is I'm going to take out my calculator and then type this one in. In part 2, I like to leave my functions in y equals section. So what I'm end up getting is 2,000 times e to the negative x squared over 20. All right, that's the function. So when I go out, I'm going to integrate this one. So math fn number 9, it was from 0 to 8, and the function was in y sub 1, so I'm going to do trace number 1, and it was against the x. All right, so I'm going to add them up. So that's about near 8,000. Now what I'm going to do is I'm going to subtract 80/50 and add 50,000. Then I'm end up getting that value. So that's around 4,9,7,8,6 liters. That's how much it's left at the end. All right, so that's basically what we can do for part C. Part D. Is there time t when the rate at which the water pumped into the tank is the same? Wait a minute, so that means what? W of t is same thing as removed from the tank. I don't know when, but one thing that we realize is, so in other words, the question wasn't when, but question was, did it actually happen? So part D, they're looking for W of t minus the fact that they're equal to each other. That means W of t minus R of t. Is that in fact ever be equal to 0? That is the question mark. Now, but we realize that W of t you can say this is the continuous and differentiable function. And second one is differentiable, that means we are assuming that it's continuous as well. So both of them are a continuous function. And when you add or subtract the two continuous functions, we realize that W of t minus R of t is continuous. And that's the prerequisite for the theorem that which we are about to use. Now let's look at then another one, because this happened between the boundaries of 0 and 8. So let's look at it. What is W of 0 minus R of 0? I'm going to use calculator to do it. So W of 0, so that means 1 of 0 minus, and this one, when it was a 0, is 1340. Then we get 660. So initially, this is 660, which is greater than 0. All right, how about the second one? W of 8 minus R of 8. And then W of 8 was, oops, alpha, parentheses 8, minus R of 8 was 700. So we get negative, okay, so negative 618.4 something, which is negative. So one thing that which we get to realize is that at one point within the boundary, it was positive, and another endpoint, it was negative. Then we get to realize that by intermediate value theorem, okay? By intermediate value theorem, there must be t where t is from 0 through 8, because those are the two values which we test upon. W of t minus R of t was equal to 0. Now, this implies that W of t was equal to R of t. All right, so something like that would have been okay. All right, with that one, I'm done with number 1. See you later.